Welcome back, students. This is the session 29 of JEE Physics. The chapter is current electricity, and this is the question which I have taken for this session. This question was asked in the JEE mains examination. It was asked in the JEE mains examination, and so this is an easy question, but here uh, there's one concept which needs to be applied, and uh, so. So first of all, just let me go through this question. The charge on the capacitor of capacitance C when the current reaches the steady state is. So these are the four options here. So this is like capacitor of capacitance C, and this is the an EMF source of magnitude E, and these are the three resistances of magnitude R, R1 and R2. Now here we have to calculate the charge on the capacitor when the current reaches the steady state. Now, what is the meaning of this line? When the current reaches the steady state, it means that that the potential difference across the EMF source is equal to the potential difference across the capacitor. Now, in this case, when the potential difference across this capacitor is equal to the potential difference across this EMF source, then there will be no flow of current through the capacitor. That is, if the potential difference across this EMF source and the potential difference across this capacitor are equal, then there will be no flow of current through the capacitor. And when there is no flow through this capacitor, then this resistance R1 will be ineffective. So it implies that resistance R1 will be ineffective. As there is no flow of current through the capacitor. So, the meaning of this steady state, that is, when the current reaches the steady state, it means that the potential difference across this EMF source and the potential difference across this capacitor is equal. And when it is so, in this case, there will be no flow of current through this capacitor, and when there is no flow of current through this capacitor, then this resistance R1 will be ineffective. So this is the meaning of this steady state. So now, based on this condition, now we have finally found that there is no flow of current through this capacitor in the steady state, and because there is no flow of current through the capacitor in the steady state, therefore this resistance R1 is ineffective. Now, based on this, I will now calculate the current in the circuit. So the current in the circuit, let us say I, this will be equal to E divided by the total resistance. Now here, since this resistance R1 is ineffective, so the total resistance will be equal to R plus R2. R plus R2. So this is the current in the circuit, which is given by E divided by R plus R2. So I have found the current in the circuit now. Now, second important point. So this was the first important point was that in the steady state, that is when the current reaches the steady state, the potential difference across the EMF source is equal to the potential difference across this capacitor, and because of this, there is no flow of current through this capacitor, and when there is no flow of current through this capacitor, this resistance R1 is ineffective. So now based on based on this analysis, I have calculated the current in the circuit, which is, say, I. So this current will be equal to E divided by the total this resistance, because now since R1 is ineffective, so the total resistance will be equal to R plus R2. So I have calculated the current in the circuit. Now, the potential difference across the capacitor will be equal to the potential difference across this resistor will be equal to the potential difference across R2. So it implies that the potential difference across the capacitor, this will be equal to the potential difference across R2 will be equal to I, that is the current in the circuit, into R2, and this is equal to this is equal to this is equal to E, because the current in the circuit is equal to E divided by R plus R2. So I is equal to R plus R2 into R2. So this is the potential difference across this resistance R2, and since the potential difference across this capacitor is equal to the potential difference across this R2, therefore we have to calculate the charge. So the charge on the capacitor is given by C into V. Now C into V. V is now this is the potential difference across this capacitor. So this is equal to C E R2 divided by R plus R2 divided by R plus R2. The potential difference across this capacitor is will be equal to the potential difference across this resistor. Now the potential difference across this resistor is equal to I into R2. I into R2. The current in the circuit is I is equal to E divided by R plus R2. So I have substituted the value of I as E divided by R plus R2 into R2. So this is the potential difference across R2, and this is the potential difference across the capacitor also. So the charge on the capacitor, that is, say it is Q. So Q is equal to C into V. C is the capacitance which is already given in this question. So C into V. Now V, this is the potential difference across this capacitor. So the potential difference across the capacitor is equal to, this is equal to E R2 divided by R plus R2. So E R2 divided by R plus R2. So the charge on the capacitor is equal to CE into R2 divided by R plus R2. So here CE R2 divided by R plus R2. R plus R2. So this is the correct option. That is, option B is the correct answer. So in this question, the most important thing which needs to be understood is that in the steady, when the current reaches the steady state, then the potential difference across this EMF source and the potential difference across this capacitor are equal. So since the potential difference across the capacitor and the potential difference across this EMF source are equal, therefore there will be no flow of current through this capacitor. And when there is no flow of current through this capacitor, then in that case this resistance R1 will become ineffective. So based on this, I have calculated the current in the circuit. That is, current in the circuit will be equal to E divided by the total resistance. Now total resistance will be equal to R plus R2 because R1 is ineffective. So I have calculated the current in the circuit, and now since the potential difference across this resistor R2 is equal to the potential difference across this capacitor, therefore the potential difference across the capacitor, which is equal to the potential difference across this resistor R2, this will be equal to I into R2, because the potential difference across this resistor R2 is equal to I into R2. Now I is equal to E divided by R plus R2. So the potential difference across R2 is equal to E R2 divided by R plus R2. So the charge on the now this is the potential difference across the capacitor also. So the charge on the capacitor will be equal to C into V. C is the capacitance which is already given in the question. So C into V. Now V is the potential difference across this capacitor, which is equal to E R2 divided by R plus R2. So E R2 divided by R plus R2. So this is how we have to solve this question, and I hope you have understood the solution of this question. In case of any doubt, all are welcome to contact me on this number also. And I will be now coming up with another question which was asked in the JEE examination in the next session. And so till then, have a nice day. Bye.